So I was discussing what is the modern definition of organic chemistry. So study of carbon and its compounds. अब ये जो carbon and its compound entirely, that is called modern definition of organic chemistry. Now usually CO2, CO, carbonate, bicarbonate, HCN, HNC, these are excluded from organic compound. So as I was saying, there is no fixed reason why. Okay, but with practice we have considered कि इनको हम नहीं लेंगे. Okay, now this is the modern definition. Next comes that what is the reason why we have this special branch? Okay, so characteristic of carbon that you need to know here, atomic number. So property, that is why I have cut that. No, I don't want to intend the word property here. It is atomic number, atomic mass, electronic configuration, covalent radius. This, I think all you already know. These are the properties of carbon. Now, then the carbon, what is so special? It's catenation property. Yes, catenation हमें important है. What is catenation? Is self-linking behavior, right? Now, this is a very specific property. Catenation is characteristic because of the high BDE, bond dissociation energy of carbon-carbon bond. I'm not saying that these are the highest bond dissociation energy of the entire periodic table, but this is quite high. And down the group, the size increases and the electronegativity will decrease, and thereby tendency to show catenation decreases, right? If we go by property, other properties, so we have others who can have catenation are, yes, silicon, germanium, but they are much less as compared to carbon. And the reason is the relative decrease in the bond dissociation energy. Then we have to know about the graphite, diamond, and fullerene, which are the allotropes of carbon. I think these are phase 1 notes. So I'm just moving forward. Okay, wherever I feel some mechanism, something important, I will stay back. Okay. So these are the bond lengths. In graphite is 141.5. Then diamond, we have single bond, which is of 154 picometer. Fullerenes does have different type of bond lengths, like single bond is 143.5 and a double bond, which is of 138.5 picometer. Now, fullerenes show aromatic nature, right? And diamond is a very dense, hardest substance on earth. So it is used as abrasive, and it has very important role in day-to-day life, but on an expensive side, of course. Okay, so see, graphite is like this, layers, layers, layers. So it is slippery. Diamond, whereas fullerene has a ring of 5 member, 6 member. Again, there is 6 member, right? So one 5 member ring is bonded to 1, 2, 3, 4, 5, 6 membered ring like this. Is that correct? And one 6 member is bonded to 3 5 member and 3 6 member rings. That is how a structure of fullerene is there. Take. It is very important to know that graphite is thermodynamically most stable allotrope of carbon, and therefore heat of formation of graphite is taken as 0. Take. Because reference frame wise we take it as 0, delta H formation of diamond and fullerene are 1.90 and 38.1 kilojoules per mole respectively. Okay, these are the usual behaviors, are the properties that you need to know. Yes, Rohit, what do you want to say?
Ma'am, you said fullerene is aromatic, then why does it have 2 different bond lengths?
Yeah, because need not, like even in naphthalene and all, you have different bond length. Na? If something is aromatic, does not mean all the bond length will be exactly equal. That depends on their resonating structure, Rohit.
Right, okay, thank you.
Right. So again, this is a primitive example, like what is sp3, what is sp2, and so I'm moving forward. What is sp? Like these all standard bond angles, and these. You know that as the percentage of s character increases, the electronegativity of hybrid orbital will increase. So like sp will be most electronegative and sp3 will be the least electronegative of the usual three hybridizations that we will need in organic chemistry for carbon, sp, sp2 and sp3. Please write these bond lengths somewhere in your notes. If you already have, very good. If you don't, then please write. Carbon single bond carbon 154, carbon double bond carbon is 134 picometer, triple bond is 120, and double bond of benzene is found to be 139 picometer, which is certainly intermediate between single and double. Okay, done. Indicate me that is done. Move.
Yes, ma'am.
Okay. So structural representation. Yes, again, I don't know whether you are reading NCERT or not, but if you have not read, please make it a ritual. Daily read some pages of NCERT. Compulsory reading of NCERT is needed for both mains as well as advanced. Please do not neglect. So if you would have read it, complete, condensed and bond line, three representations are there in NCRT. Complete matlab you write each atom, you represent each bond, then it is complete. Condensed, you just imagine as if all these bonds are like stick and you compress, all the sticks are now invisible, and simple CH3 dot CH3, CH3 dot CH2. This type if you are writing, then it is condensed. Okay, yes, you have to remember that while writing this type, whatever like CH and CH if I'm writing, so whatever bond you feel is not satisfied will be satisfied amongst themselves. So maintaining the tetravalency of carbon, you have to assume the proper structure. Okay. I would like to add one thing, beta. All of a sudden, the weather conditions in Hyderabad has just deteriorated. So, in case if electricity gone and network gone, just be in the meeting. Okay, I'll go on the generator or the inverter. It will take few minutes to for me to be back. Okay, I can see across the window. All of a sudden, it is a little windy and the weather is like that. I may get an electricity cut or something. So if it happens, just be in the meeting. Okay, do not leave. Wait for me to be back for in three minutes, 4 minutes. I'll be back. So let me continue. So bond line notations. When we talk of bond line, then we do not represent carbon and hydrogen. We do not represent, rather I should reframe, we do not write carbon and hydrogen, and we write simply the bonds between those atoms. But if there is any other atom than carbon hydrogen, then we do write them as proper atoms. Like, see, ethane, I'll just put a stick. Okay. Ethene, I will put like this. Ethine, I will put three dandas. Ethanol, I will put like this. But I have to write now OH. In case I would have not written OH, if would have left like this, then it is taken as propane. Okay, CH3O, CH3 and all these. Right, benzene, I will write something like this. Some important molecules that you need to know, of course, benzene. Yeah, please see how many pure or unhybridized orbitals are there in C6H6. Similarly, you can practice 1,3-butadiene, right? Kindly do this question. Maximum number of atoms that can be in one plane in 1,3-butadiene is. Now, what is cumulative diene of polyenes? Allenes. So like these will be allenes. The word is derived from all enes. Like all bonds are enes, then it is called allenes. Right? This is the geometry. Of course, for initial phases, it is right. Now coming to degree of unsaturation. Now, degree of unsaturation is also known as index of hydrogen deficiency, double bond equivalent, unsaturation index. All these are names of degree of unsaturation and the abbreviation DOU, IHD, DBE, etc. Okay, C plus 1 minus H plus X minus N by 2 is the formula Very good. We know the formula. Now, the very important point is, what is degree of unsaturation? Degree of unsaturation, please remember, is a chemical terminology, is a mathematical expression, and unsaturation is a chemical terminology. Okay, so what do I want to say with this particular thing? See, if I say a compound is unsaturated, what does it really mean? So I was telling that degree of unsaturation is DOU, IHD, DBE, unsaturation index, and there is a formula. Very good. We have a formula. How to use it? Do we depend on formula? I'll say not always. We have to be very open, like how to use this particular concept. First, let me differentiate for you what is unsaturated compound and what is degree of unsaturation. Okay, so unsaturated compound, if I say this compound is unsaturated, it should have some chemical behavior to satisfy, some chemical reactions to exhibit, then it is for unsaturated compound to be called. Okay, now what is that behavior? A compound will be called unsaturated only when it shows unsaturation test, which are bromine water decolorization or cold dilute alkaline KMNO4 decolorization. These, if we see, then we call those compounds to be unsaturated. Now, when I say unsaturated compound, I do not intend to say that there is a presence of pi bond. For example, yes, benzene has a number of pi bonds, but does not to be inferred as an unsaturated compound. Cyanide, yes, it has pi bond, nitro, carbonyl, but these are the compounds which will not give the electrophilic addition reactions which are used, okay, which are used for compound to be named or considered as unsaturated compounds. So for a compound to be referred as unsaturated compound, compulsorily should give bromine water reaction or Bayer's reagent test. That out of these, if it shows some reaction, then only you call it unsaturated compounds. Whereas when I say a compound, whenever I say find a degree of unsaturation, degree of unsaturation, beta, is a mathematical condition. Okay, what is it? It is a mathematical condition in which we define some condition. Now, what is that condition? Let me tell, please listen carefully. Number of moles of hydrogen molecules required to convert given molecule into fully saturated, in bracket we'll write all bonds should be single bonds, comma, open chain structures, okay, is called degree of unsaturation of that compound. Let me repeat. Number of moles of hydrogen molecules required by 1 mole of a given compound to be converted to fully saturated open chain structure is known as degree of unsaturation of that compound. Absolutely clear now? So degree of unsaturation is something which is a mathematical condition. Here we are not saying it should give this test, it should give that test, or it should behave like this. No, nothing. Now, when I have this, that okay, degree of unsaturation is a mathematical condition, after that you have to think for two things. Two things, what I want to say is either the question will be in terms of formula or it could be in the terms of structure, right? So if it comes as a formula, right? If it comes as a formula C6H6, C3H6O like this, in these, the use of this formula is very appropriate. You can go by this. C plus 1 minus H plus X minus N by 2. You can use this and continue your question. Okay. But if you come across with a structure, then it is your choice whether you convert it to the CXHY type formula and then apply that degree of unsaturation formula, or you can directly go by, like for benzene, just remove the pi bonds. One pi bond will require two hydrogen atoms. two hydrogen atoms, one hydrogen molecule, so 3, and one ring opening, so total DOU is 4. Okay. Similarly, in naphthalene, 1, 2, 3, 4, 5, 6, 7, DOU is 7. Right? In cubane, this compound is called cubane. 1, 2, 3, 4, 5. Right? And so on. 13, and this is how you can do. Now, it is entirely your choice. Whichever way you are comfortable, you can use these reactions. Okay. Is that clear? How to solve these questions? But you need to know use of degree of unsaturation to have good command over other questions in future. Now let us start with the organic compound are classified as. Again, I am using reference as NCRT. So acyclic or open chain. Yes, Shrey, please speak.
Ma'am, can you please go back to the last slide?
This one.
Yeah, number 6, why is it 2?
Shrey, I am using 2 because I will have this as 1 and this as 2, na beta?
But why is NO2 counted as?
Oh, then you didn't pay attention, Shrey. I said degree of unsaturation is a mathematical expression in which number of moles of hydrogen molecules required to convert given molecule into fully saturated open chain. Fully saturated one here and one here, 2, na?
Okay, so I mean, just all double bonds or triple bonds to see.
Yes, all double bonds, all triple bonds, whether they are only of carbon-carbon or other species.
Okay, thank
Is that clear?
you. Yes, sir.
Okay. So that is how we do a degree of unsaturation. Yes, Sanjay?
Ma'am, can degree of unsaturation can be defined for ionic species like carbocations or carbanions or anything else of such?
I don't find the need for that. I don't know how will I hydrogenate them. These are the reaction intermediates, Sanjay. It is a very hypothetical question. Why would I do that?
Okay, ma'am.
So saturated and unsaturated we were doing. We have already defined now the what is the chemically saturated and saturated. Here the chemical, I'm not saying degree of unsaturation. Then here comes the cyclic or closed chain or ring compounds. Okay, so it is homocyclic or carbocyclic and the heterocyclic compounds. So if I talk of homocyclic, it could be again alicyclic or aromatic. Aromatic are further as a benzenide and a non-benzenide compounds. Heterocyclic as alicyclic and aromatic compounds. Okay, like that we classify. Now, there are some important terms that you need to know, like acyclic. Any compound which is open chain is called acyclic compound. It could be saturated, it could be unsaturated. We are not referring anything with respect to this. Any compound which is open chain is called acyclic compound. Like this ether, this alkane, all these are called acyclic compounds. Alkenes or alkynes are unsaturated but still are acyclic. Okay. Cyclic compounds are alicyclic. They will be called cyclic compounds are either alicyclic or aromatic compounds. Coming to what is alicyclic, as we have defined, cyclic is of two type, ali and aromatic. So alicyclic is alicyclic compound contain one or more rings, which may be either saturated or unsaturated, but do not have aromatic character. So they can be saturated and unsaturated, but they should not have aromatic character, right? Then they are called alicyclic. Out of this, there are homocyclic, which are like this, or it could be heterocyclic, like oxygen, nitrogen, sulfur, all these are heterocyclic compounds. Aromatic, when they satisfy the condition of aromaticity, then it is aromatic. Either it could be benzenoid, it could be heterocyclic systems, it could be non-benzenoid. Non-benzenoid bole to it should not have a benzene structure in it, like tropone, cyclopentadiene, anion, and so on. Then we have the types of carbon. Please remember this is a general definition that we are using but modified as per the latest NCERT. 1 degree of primary, okay, when the carbon is further connected to either one more carbon or no carbon, and as per that methane is now taken as a primary carbon. Okay, so 1 degree of primary. 2 degree when a carbon is further connected to two more. 3 degree connected to 3 tertiary, then 4, and so on. You must be aware of this terminology also. Vinylic carbon, carbon double bonded carbon. This carbon is called any of these, huh? This and not this one or this. Any of this double bonded system may say we take one carbon will be referred as vinylic carbon. Allylic, see this propene system. In this propene system, this sp3 carbon is called the allylic, right? This is the basic. Now, if I have this type, yes, I have two allylic carbons, this CH3 as well as this CH2, two allylic. Benzylic, benzylic ring, and then the next carbon to ring. Immediately attached next carbon to ring will be called benzylic carbon. Okay. Phenylic carbon is the carbon present in the ring. Is that clear? Phenylic carbon is the carbon present within the ring is called phenylic carbon. Types of hydrogen. Similarly, we proceed at the primary hydrogen, that is the hydrogen attached to primary carbon. Secondary is the hydrogen attached to 2 degree or secondary carbon. Tertiary hydrogen, carbon which is 3 degree, the hydrogen attached to that 3 degree are called tertiary hydrogen or 3 degree hydrogen. Okay, and similarly, vinylic hydrogen, as we just discussed, vinylic carbon, hydrogen attached to vinylic carbon will be referred as vinylic hydrogens. Okay, so this is how they are named. Moving to allylic hydrogen, same way benzylic and phenylic. Count number of allylic and vinylic carbon and hydrogen. No need for you to do at this stage. Find number of benzylic carbons in the following compound. Yes, you can do that. Number of 1 degree, 2 degree, we do not need to stop. Coming to functional groups. An atom or a group of atoms in the molecule which control most of its physical and chemical properties. As the name suggests, the functional part of the molecule is called functional group. Okay, the functional part of the molecule is called the functional group of the that molecule. It could be an atom or it could be group of atoms. Okay, so there are so many functional groups. Even alkene and alkynes are also type of functional groups. They are taken as a separate functional groups. Similarly, you must be aware of the fact what are the degree of alkyl halide, degree of alcohols, degree of amines. But yes, there is a difference in degree of alkyl halide alcohol versus degree of amines, right? Alkyl halide alcohols are like primary, secondary, tertiary, similar to the way we refer the hydrogen. If halogen is attached to a primary carbon, then we call it as a primary alkyl halide. If it is attached to a secondary carbon, then we call it a secondary alkyl halide. Tertiary carbon, then tertiary alkyl halide. Whereas in case of different degrees of amines, we refer degree with respect to ammonia. Okay, the number of hydrogens we displace from this ammonia and form amines. If I displace only one hydrogen, RNH2, then it is primary amine. Now I am totally independent of what the nature of the carbon with which my nitrogen is attached. If I simply remove 2 hydrogens, I will call it secondary amine. If I remove 3 hydrogens, it is called tertiary amine, right? Again, a next important point, what is a homologous series? A series of compounds having same functional group, having a fixed difference of CH2 or a 14 units mass between two consecutive members, then it is called a homologous series, but the homologue is any two member of that series. We do not look for a consecutive member. Any two member in that series will be referred as homologue of each other. Like methane and decane will be homologues of each other. Okay, they are very much homologues of each other. Okay? Is that clear? In case of homologues, you will have the same general formula, same empirical formula, same functional groups. Okay. And that's why you will ultimately have similar chemical and physical behaviors. Physical behavior, I don't want to say the exact similar in terms of like same boiling point, same melting point, but a similar, right? Relatively, behavior is same. Homologues are not isomers, certainly, because they do not have the same molecular formula for all the homologues. Okay, so those are the homologues. Yes, here when you identify the homologues, like first pair, if I say primary and secondary alcohols, they are certainly homologues. Primary amine, tertiary amine are not homologues because in homologues, I told you should have a same functional group, whereas different degrees of amines are taken as different functional groups. Okay, different degrees of amines are different functional groups. So 2 is not a homologue. Aldehyde and ketone are different functional groups, so they are not homologues. Phenol and alcohol, they are definitely not homologues. They are different functional groups. Homologues must have identical functional group. Okay, draw first homologue. I don't think you need that at this time. So I'll move to my next lecture. Just give me a second to open. Yeah. So let us move further. Nomenclature of organic compound. Yes, very, very important, trivial or initial, and then the IUPAC. Right? This is how we proceeded with nomenclature. Now, I don't need, I think, because it is what you might have already been taught, nothing much in nomenclature. Kindly suggest me, can I skip nomenclature and directly move to isomerism? Please interrupt me. I'm waiting for your suggestion. If you want, I can go to nomenclature also, doesn't matter. Okay, if you think that I will, you need it, then 2, 3, 4, 5, 4 lectures are there for nomenclature. If you want, I will revise them. Please vote or please tell whatever your opinions are. Anyone? I don't find anyone speaking.
Can we
So,
just revise some rules?
okay, okay.
Yes,
Let us
please.
go to certain rules. Okay. Shrey, when I'll start the IUPAC, I might have to, because I'm not aware what are those some rules you are saying. So then I have to complete all those 4 lectures. Is that fine with you?
How much time will it take?
And this I'm talking to, hello, Shrey? Was it
Yes,
Shrey
ma'am.
or was it?
Yes, ma'am.
Okay.
That's me.
No, no, who asked how much time? I'm talking
Yeah,
to
yeah.
whom?
it was me.
Okay. So it depends. Like usually it will take 2 classes hardly. Like tomorrow and day after tomorrow in 2 classes we'll be done. 2 lecture per class I'm targeting because it is like revision, na? Not I don't have to stop at each point, just the major points where you want to discuss. So tell, comment again.
Yes, ma'am. We can do nomenclature.
Also, okay.
Yeah.
Okay, that was Shrey. Ashish, you are also unmuted. Would you like to add something? Do you want to say something? No? Okay, Mahil, is there anything you want to add?
Nothing.
Nothing is fine, but should I do nomenclature? Are you okay with that? That was a question for Mahil.
Ma'am, no need. You can continue.
Okay, I got a little confused, but I assume I should continue. Okay. So we are not doing the trivial nomenclature thing. Let us come directly to IUPAC. So in IUPAC, we have prefix. Prefix, remember, primary prefix, secondary prefix. Primary is cyclo, bicyclo, etc. Secondary is like the location, positions when you say, or the branches you refer as a methyl, ethyl, or whatever. Those are the secondary prefix. Then you have the root word and the suffix. Primary suffix is an, in, ein, and secondary suffix is all, oic acid, al, on, amine. Okay. So as far as Shrey said that we should be mainly concentrating on the important rules that are the probable places where I think you may stumble. So I don't think hydrocarbon is an issue. I'll just verbally tell first count the maximum number of carbon possible in a linear unbranched chain. According to that, assign the root word. Decide the suffix as per the carbon-carbon linkages present in the molecule. All single, use ane. Even one double, use ene. If triple bond is there, then use ein. Only three possibilities, ane, in, ein. Just add it to the root word, meth and ane, ethane, ane, propene, and all these, and you will get the name. Okay. Then how to name the alkyl groups. Alkyl groups are to be named by, you use the original alkane. For example, if I have a CH3, so what is the alkane? Methane. Remove ane and add yl, AYL. Okay, that is methyl or alkyl. That is how you get the alkyls. So from every this alkane, we have practiced what alkyl. So methane, I'll get methyl. Ethane, I'll get ethyl. When I talk of propane, I get two possibility, either from 1 degree, so I get a N-propyl. So N-propyl could be written in any of these formats, C3H7, N-propyl, N-propyl, any of these format, or I could get a isopropyl. From a 2 degree, if I get a bonding, isopropyl. Like, then always remember the iso has to have only this 2 methyl as a branch. V should be of methyl. Need not to be one ethyl, one methyl. No. Compulsorily, methyls are in this branch. If I have a 4 carbon, then I have from 1 degree, N-butyl say I'm making, so N-butyl, then 2 degree, then secondary butyl. Right? If I have a pentane, then similarly I go, but now I have 2 possibilities of secondary carbon to go for bonding. So out of these 2 possibilities, how to differentiate? So one is a chiral, 2 ethyls are there. So usko we have named secondary pentyl, whereas the one which is chiral, we name it as active pentyl. Okay. Going further, if you have isobutane, then you use the word isobutyl if you have a branching or if you have a substituent located at CH3, any of the primary carbons, then you call it isobutyl. If you remove the H from this center, okay, then like this, then you call it tert butyl. What you call it? Tert butyl. Neopentane, then you call it neopentyl. Okay. Similarly, alkene is substituent, then you call ethene, ethenyl. If you have a propene, if you are having a branch at sp3, then you either call it allyl or you call it 2-propenyl. Okay, 1-propenyl and like this, right? This is ethynyl. Once you are done with this, then you select the longest carbon chain as parent. If 2 chains have the same number of carbon, then select the one which has more number of branches. Okay. If the 2 have same number of branches, then you select the one which has lower locant set, lower position set, right? Then comes the position set. Select the one with lower locant set. Moving further, if I have like in a complex name, the letter starting the bracket is considered for alphabetic order. Like, for example, this up 1, 1, 2, 3, 4, this up 1. See, this is the parent, है 3 dimethyl, 4 2-methyl propyl. Okay, so this position number 4 has this portion as 4 2-methyl propyl. So for alphabetizing, I will use M. It is a complex bracket. So first letter M, and this is simply propyl. So I will use P. So in a complex bracket, the first letter which appears is used for alphabetizing. Okay. In case of numbering, always select the starting end from where you get the lower position or the lower locant possible for all the substituent. And only locant rule is in existence now since last 20 years. There is nothing like lower sum rule. Okay, there is nothing like that. Only you have to use lower locant rule. Is that clear? Moving further, if from the two ends we get same sets, then we have to number the parent chain so as to the substance starting with alphabetical order appears first. But this is only when the set is same. If I go from left to right, I have a set of 3, 6. If I go from right to left, again I have a 3, 6. Now, as the set is same from both the directions, so I will prefer where the E and M, when alphabetized, E getting the lower number. So I want this side, left to right. 3-ethyl, 6-methyl octane. Okay. If you have a cycloalkane, then all the above rules like the locant, like the substituent and everything remains same. The only thing which you need to have extra is the root word is now prefixed with the word cyclo. Cyclohexane, cyclopentane. Rest all rules will remain same. Okay. 4-ethyl, 1,1-dimethyl cyclohexane. Is that clear? Now here you see, this is 1, 1, 4 trimethyl cyclohexane. When the set has got same, then I will say 1-ethyl 4-methyl. Here I will not say 1-ethyl 4,4-dimethyl because 1-ethyl 4,4-dimethyl will be a bigger set than this I am using currently in this yellow. Absolutely okay, right? So the rest is same. Now this page is important. Please, if you can take a screenshot, please take. If the molecule, or if you don't, then write. If the molecule has both cycle and open chain, okay, like these, cycle and open chain. Now there are 3 possibilities. Either the number of carbon in the cycle and open chain are equal, or I can say cycle carbon chain greater than open chain or open chain carbon chain greater than cycle. There are these 3 possibilities. So if the number of atoms in cycle is greater than equal to open chain, then the cycle is the parent chain. Even if they are equal, then also cycle is the parent chain. We are talking when there is no functional group. See, this is 5. 1, 2, 3, 4, 5. This is 5. You will call it N-pentyl cyclopentane. Okay. And certainly if in equal this is the case, then if these are greater, then also certainly this will be the parent chain. If the number of carbon atom in cycle is less than the open chain, then the open chain is the parent. Okay, then open chain is the parent. For example, here, 1 cyclopentyl hexane, 1, 2, 3, 4, 5, 6. Now coming to this, 1, 2, 3, 4, 5, 6, 7, like this. So this will be 3 cyclopentyl heptane. Is that all good? Right? Coming to next point, if there are 2 cyclic groups attached to one open chain, then irrespective of the carbon count, always the open chain become parent. 1, 2, 3. So I have 2 substituents. Na? So 1, 3 dicyclohexyl propane. So if there are more number of cycloalkyl groups present on my open chain, then I'll take open chain as a parent. And a very important, this green mark, green star mark, cyclo of the cycloalkyl is used in alphabetizing. You have to consider it while setting them in alphabetical order, right? And then we move to alkenes and alkynes. So yes, select the parent chain having maximum number of multiple bonds. And even while maintaining the maximum number of double bonds or a multiple bond in the parent chain, you can compromise on the longest carbon chain rule. That is allowed. See, for here, I will not take 1, 2, 3, 4, 5, 6, 7. I will not take 7 as a parent. Okay, I'll rather take 5 as a parent. So that is what I'm saying. You can compromise on the maximum carbon in the parent chain rule. You can call it 2,4-diethyl, 1,4-pentadiene. Similarly here, 1-hexyl cyclopentene. Okay, number the parent chain from the direction having lowest number to the first appearing multiple bond. I'm not saying alkene or alkyne. It could be any one. You have to number, you have to start numbering from the direction where the first appearing multiple bond has the lower number. Okay. Now see, if more than one double or triple bonds are present, then we can use diene, triene, tetraene, etc. But for using such suffixes, we have to add extra a in the root word. Like see, you are already habituated to the word butadiene. And 1, 3, why don't you call it butadiene? No, na, you call it buta. So you always add extra a in the root word when you are having a following up suffixes diene, triene, or ein, in, whatever, but di, tri, etc. Then you add this extra a in this root word. Is that clear? See, pent a 1,4-diene, like that. Is that clear? If you are having a different thing, di alag and tri, यानी कि alkene hai or alkyne hai, then you will not use ditri. So you will write hex 1 in 4 eine. But remember, you have to shed the last e of a primary suffix if it is followed by a vowel sound. I'm not saying vowel sound, a, e, I, o, u sound. So this is, yes, starting with y, but the sound is ein, university, and umbrella. That comparison we are having here. A university, yeah, you. Whereas an umbrella, that way y is taken as a vowel sound. So I have to shed this e from in, and I will write hex 1 in 4 ein, removing this e. Is that exactly understood? And similarly here, I will start with 1 ein, 4 in. If both double and triple bonds are present, then while writing them in the name, place them in alphabetical order. That is, in is written followed by ein. If primary suffix is followed by a vowel sound in the name, then drop the last e of it. You have to remove that last e of it. Is that absolutely clear? And while numbering, always prefer double and triple bond over any alkyl or any substituent, I must say. Okay, secondary suffix is the most important while locating, while giving the position, and then comes the double triple bond, and then comes any of the prefixes, any secondary functional group or whatever. Is that all clear? Like all these. Right? And that brings us to the closure of our second lecture. That is how I'll take. So we are done. Out of 5 lectures of IUPAC, 2 are done. Similarly, we'll do 2 again tomorrow. And day after tomorrow, we'll be done with IUPAC. Right? So that brings us to today's class. I think you must be having following up class. Is there anything you want to ask us about? Yes, Rohit, please tell.
Will you be sending all of these or
No, beta, these are my personal notes. I will not share these notes directly. But if you want to write anywhere, please make me stop.
I know, understood. No problem. Thank you.
Thank you. Anyone else? Any doubt? Okay, okay. But please sit with your phase one notes along with you, because I am sure you must be taught enough theory. Just few points here and there you might have to, just add or revise. You add and please sit with some loose papers so you can just punch over there and things will be like complete as per me, and then we can proceed again for further revisions. Yes, Ashish, please tell.
Ma'am, what is the timings of the class? I doesn't know.
Ashish, 5 to 6 written.
Okay, ma'am.
Okay, 5 to 6 p.m. is what we have decided. If there will be any change, we'll let you know.
Okay, ma'am. Thank you, ma'am.
Okay, beta. Okay, bacho. Continue. We'll meet again tomorrow, same time, 5 to 6. Thank you, everyone. Good night. Yes, Mahil.
Ma'am, pentane, and then one end is double bond, one end is triple bond. How do you name
But,
it?
wait. You are telling of a structure, Mahil.
Yes, ma'am.
Wait. I have to write. I never answer without writing. I am not as smart as you young generation people. So repeat.
We have a pentane,
Pentane. So you can see the screen na? Wherever I make error, let me know. Yeah.
one end
Pentane.
double,
One.
one end double bond,
Ah,
and one end triple bond.
like this.
How do you name it, ma'am?
1, 2, 3, 4, 5. See, Mahil, I will definitely have two choices. I can either go this way or I can go this way. Okay. Now see, the set is same, Mahil. If I go from yellow like this, still the set is 1, 4. If I go with white like this, my set is 1, 4 only, Mahil. Say yes or no.
Yes, ma'am.
Right? So when the set is same, we follow that the one appearing first in alphabetical order should be given lower number. So in versus ein, first appearance is of in, so I will use this order and will reject this. So I will name it as pent is my root word. One in, and I will shed that last T. Right? Do you remember the vowel thing I just told you? Four ein. Is that okay, Mahil?
So there's no exception
For what?
of naming iron.
No, there is nothing. See, Mahil, can you see these examples?
Yes, ma'am.
So these are like solving the same similar. Only if see in is appearing first, like set is not followed, then I will do this thing that in is preferred. But here I made immediate example so that it is not about preferring in over ein or ein over in. It is just following the locant rule always.